as well as we actually apply the theorem of on cyclic quadrilateral. So now we want to continue with the application of the theorem. So we want to solve as many questions as possible. At the same time, you can recall very well. So those questions we solved in the last class happens to be those questions that only require the application of what? The cyclic quadrilateral theorem. That is, those questions we solved in those sessions didn't have anything to do with any other three theorems that we've learned so far. But as regards the question we want to solve from the very one which we have on the board and many other questions which we are going to be talking about now, so they are the questions that has to do with application of the whole, that is the generality of the theorem which we have learned so far in this class since we began our discussion on what? On the circle theorem. Now, by the first question which we have here, so this is the question. And we have to find the angle ACE, which is this aspect here. Now, to doing this thing, so we just have to think of the overall theorem that we know. Overall theorem that ever exists. So, when we think of those things generally, so we're able to what? To actually capture, to be able to actually obtain the result which is expected of us. Now, to deal with the first question which we have here, so I first of all think whether I can be able to what? Whether the first theorem will work. And you can remember very well, the first theorem is the one that tries to draw a relationship between what we have between angle at the center as well as what? As the angle at the circumference. And we can see that theorem is not going to what? To be applicable in this case. The reason being that what? For that theorem to be applied, angle at the center has to be given. And when we look at this thing very well, so we are going to see that at this center here, we can see this is an indication of center. At this center here, we can see that what? No angle is given, no angle is formed at the center of this circle. So since no angle is formed at the center, so that means the theorem which talks about what? Relationship between angle at the center as well as angle at the circumference is not going to what? Is not going to be used. So from there we move over to another theorem, that is the second theorem. So what we know as the second theorem is the one which talks about what? Angle in a semicircle. And to deal with angle in a semicircle, the first one we have to do is to what? To be able to identify the diameter in the diagram. So what is the diameter? We know, we talked about it. We talked a lot about it in the previous class. So we said diameter is that line that passes through the center of the circle. So since this is the line that passes through the center of the circle, so this is going to be the diameter. Now, having identified the diameter, then the next one we want to do is what? What are the two endpoints of the diameter? So we can see the two endpoints of this very diameter we have are point A here as well as the point C here. And what we want to do with these 2 points is that we want this point to move, as well as these 2 points. We want the 2 points to move in such a way that they will meet at one particular point where on the circumference of the circle. So at that point, angle formed at that point is what we are going to term what? Our angle in a semicircle. And if that is done very well, so we know movement, the first movement from the first endpoint has to be from here down to D. And the expectation now is that when we move from C now, so we want the destination of the movement to what? To also be on point D. And we can see that when we move like this, when we move this way, we can see that it also what? It also stop on point D, since both point C and C are able to do what? To come to a point D. So we serve as what? Another angle. So we can see the point D here now gives to us angle that runs from this line down to this line. So the angle so formed there is what we call what? The angle in a semicircle. And by the theorem, such a theorem will have the value of what? 90 degrees. So it shows this place is what? Is 90 degrees. Now, having done that, so let us also check. Is it possible for us to as well reapply this theorem? That is the theorem of the theorem that talks about angle in a semicircle. Is it also possible to walk over that theorem once again so as to obtain any other angle? That is, do we have any other angle in a semicircle? So in order to do that, so we have to move somewhere else. So this is the diameter. We have these 2 points. Let's see if the movement is possible. So we can say one movement from point C is to point B. And no matter how much you try to move from this point, you can't move direct to B, except if the question dictates such for us. So the maximum we can do is to move from here to here. So which means, the theorem that talks about what angle in a semicircle can only be applied once here. So that about what the second theorem. Now we shift our attention to the next theorem, so which is the one which talks about what angle in the same segment. So, and remember, the application of that angle in the segment is a relative form of angle. That is, it's an angle that talks about relationship between two or more things. So which means that what it's only when one angle is known, so we try to compare which other angle has that same feature. Now, and as at the moment, only two angles is given to us. So those two angles given to us are the angle 127 as well as what the angle 90 degree. So I can see that no matter how much I try to move, the angle 127 degree which I have here is in no way, they have anything that we can see angle 127 is on chord AC. Do you have any other angle that is having this line AC here, that is the chord AC here as its base? So such doesn't exist. So it also shows that what the third theorem, which talks about what angle in the same segment, is not applicable. Now we can now move over to the fourth theorem. So the fourth theorem is the one which talks about what angle in cyclic quadrilateral. So we can see there that we were told that angle in cyclic quadrilateral are what? They are supplementary. Angle in cyclic quadrilateral, they are supplementary. So to apply that property, so what we are going to do is we need just an equilateral, and we need a quadrilateral. Because when we observe this question very well, you can see that this question is beyond the case of quadrilateral. So in fact, the shape which we have within this circle has 5 sides, so we can read it from A, B, C, D, E, which is 1, 2, 3, 4, and 5. So which might not be possible, but there is a way we can adjust the situation we have here so that we can form a quadrilateral. So in a situation whereby we want to form a quadrilateral, what we rather do is we rather concentrate on any 4 points. That is, we concentrate on any 4 angles. So thereby we pick any 2 angles that faces or that are opposite to each other. So in that wise, what I can do is I can pick this point. What I can do in that situation is I will pick this angle B as well as angle D. So what I mean by angle D then is I will concentrate on point A, point B, point C, and point D. So that those are 4 points, and 4 points in that situation will give what? 4 angles. So out of those 4 angles, let's go to here where angles are given to us. So we can see angle A is opposite to what? The whole of angle C here. But since no value is here nor here, so we can't go into that area. We can't move into that area. But our solution can begin in that aspect. And the next thing we can do is we also know that since we are considering ABCDs, so once A and C are not making sense to us, then let us check angle B as well as angle D. Remember, it's ABCD we are using. So in that wise, it shows that this point from this angle that starts from here to here, we will treat it as being opposite to this angle here. Remember, the angle from here to here, we want to treat it as being opposite to angle from here to here. So if we treat it that way, then we can now bring in the property of what? The cyclic quadrilateral. So remember, the property says that what? The opposite angle of cyclic quadrilateral are supplementary, which means that what? Addition of this angle as well as what I have here is 180 degree. But since exact angle here is not given, remember the 90 degree here cut across this angle down to this place. But the one we are interested in now only carries information from here to here. So we need the angle here. So since the value of the angle here is not given, so we can give it its proper name. The name we can give to it is, since the angle is D, we can name it ADC. So in that wise, we say that ADC plus the angle which I have here, we can name that one ABC plus ABC here is equal to what? 180 degrees. And what is the reason behind this? The reason is what? Opposite angle of a cyclic quadrilateral are supplementary. That is, opposite angle of a cyclic quadrilateral are dropped to what? 180 degrees. So to continue with this, remember we don't know angle D here. So that is, we don't know angle ADC. So we write it as ADC plus, but remember ABC is given as what here? 127 degrees. So we say this is equal to 180 degrees. So to get my ADC here means I will have to collect the lighter. So in that wise, I can say that ADC is what? 180 degree minus 127 degree. And ADC in this situation gives the value of what? 53 degrees. So we can see that our ADC here is 53 degrees. So it shows that ear to ear is 53 degrees. And when we observe this diagram very well, we can see that the whole of the angle from ear to ear, that is the whole of angle EDC. Remember this angle EDC here, this entire angle here is subdivided into two. It comprises of this one angle as well as this angle here. In short, we can say that this angle D, that is angle EDC, is equal to EDA plus ADC. Now, since the whole angle here is 90 degrees, part of it is known to be 53 degrees, then what's going to be the remaining angle? So the remaining angle is going to be determined by what? Subtracting this value from what? 90 degrees. So this is what I'm saying. The whole of this angle is 90. But part of it is known to be what? To be equal to 53 degrees. So what is going to be this remaining angle? The remaining angle is going to be the value we obtain when we what? Subtract this 53 from what? 90 degree. And when we do that, the result we get there is 37. So it shows this place is what? 37. So my 37 is here because this space is too small to accommodate my what? 37 degrees. So this portion here is what? 37 degrees. Now we can say that all the theorems we have learned so far, we've applied them. Now that we've applied them, let's now go back to what we are asked to do. So what we are asked to do. So actually what we are asked to do is to find this portion here, this angle ACD. Now to find angle ACE. So to find an angle ACE here, so there what we can do is let's see where we have angle ACE. So we can say our angle ACE is on this chord chord AE. Do we have any other angle that is also resting on this chord AE? Or is angle C here sharing this chord AE with any other angle? When we look at it very well, we are going to observe that this portion here too, that is the one we call 37, that is angle ADE rather, is also what? On this chord AE. How? Now, let's say this is the point of the angle. So, at this point, two lines form the angle we have at D here. Those two lines are this line as well as this line. So, from these two lines, let's try and move until we get to circumference of the circle. So, for the two lines and C, or on what chord is those two lines resting. So, we can see when we move here, this one will come down to A here. From here, when we move, it will come to E. So which shows that what angle D is as well resting on this same AE, that angle CE, that is that angle ACE is resting. So it shows that what angle ACE is on the same segment as angle ADE. So that shows that what ACE is equal to ADE is equal to ADE. Now, what is the reason behind this? The reason is angles in the same segment are equal. So we can now progress by saying that angle ACE is equal to, now what is the value of AD? You can see ADE on the board there is 37 degrees. Is equal to 37 degrees. So we choose what we are asked to find. The angle ACE has the value of what? 37 degrees. So that's our third question. So we move over now to the next question, which is number 4. In number 4, I have this. Q, P, S X center O. This place is 77 degree and this place is 68 degree. And we are asked to do what? To find P, Q, O. So here we have to find angle Q. So find angle Q in that situation. Now we are interested in finding angle Q. So the same thing we have to what? Keep thinking. What are the what? Right principle that can be used there. So let's begin with the first theorem. So normally in a standard question like this, one has to begin reasoning from what? From the first theorem. So one just have to think of every available theorem. So and the way I'm going to solve mine is what? I will begin with the first theorem that we have. Now the first theorem is the one that talks about angle at the center as well as what? Angle at the circumference. So we can see in this, when we have this type of pattern, this type of shape, there are two things here. One thing is this diagram here. Another thing is this and this diagram. So that is one thing. Now when we have this, in each of the two situations here, what the most important thing we need is angle at the center or angle at the circumference. So one of the two has to be mentioned. Now when we look at this thing very well, so if you are considering the lower diagram here, we can see this is where we usually assume to be center, and this place is what we assume it to be angle at the circumference. So in this case, angle at the center is not given, angle at the circumference is not given. So then before we think, or before we are going to say that what that property is not will not work, will not hold here. Another thing we are going to do is let us look at our diagram very well. Is there any clue as to getting either angle at the center or angle at the circumference? Now the clue is, if here is supposed to be my center, I will have to come and check an angle which is reflex to this angle here. If such an angle is given, it shows this is given indirectly. So with a little thinking, we'll be able to obtain what is the angle at the center. But we can see, since this is not given, then definitely we will not no information about angle at the center here at all. At the same time, let us think: is the angle at the circumference given? That is the circumference facing the center. So we can see that is not given. Normally, the circumference is supposed to be here. So is that given? We can see that is not given here. So let's say for the main time, maybe that theorem might not be useful. Another thing we can do is, let's go back to the second diagram here. That still calls for what? Application of the first theorem. So in this kind of diagram, do you get it? Here usually happens to be our center. Is the center given in this case? You can see angle at the center is not given. Since angle at the center here is not given, now let's consider the angle at the circumference. Now, are we given any clue as to getting angle at the circumference? So that is, its circumference is going to be here. But when you observe the 77 here, it has some relationship with this place. The relationship with it is that there is a particular straight line that moves this way. That is, the QPS is a straight line. Something that happened to this straight line. What happened to it was that this straight line was divided into two. It was what? It was divided into two. And remember, whenever an angle is divided into two, that is, when we bisect any straight line, so the combination of all the angles on that straight line, addition of all the angles we can have on that straight line, will give the value of what? 180 degrees. So that is the property which states that what? Sum of angle on a straight line is what? 180 degrees. So which shows that combination of this place and this place gives the value of 180. So that is where we can start with. We can start our solution with. So in that case, we can say this place plus this place is 180. Now how do we name that? I want to name this angle, so I may call it QPS. So in that way, I will say QPS plus the angle, the other angle which I have here. So since this is the angle, I can call that one XPS plus XPS is equal to 180 degrees. So reason for the sum of angle on the straight line is what? 180 degrees. And since QPS is not given at all, we write it as QPS plus, and what's our XPS? So you can say SPS or SPX has the value of what? 77 degrees is equal to what? 180 degrees. So which means to get QPS here, We want us to do what, to collect the item. So in this case, you can say QPS is equal to 180 degree minus 77 degree, and QPS in this case rather, gives the value of so that gives the value of 103 degree. So in that case, you can write 103 degree here. You can write 103 degree here. And when we have this type of diagram, I can jump now. I can move between theorem anyhow. So in this case, I can say that with what I have here, this is 1 point, second point, third point, 4 point. I can as well assume that what I have here is what? Is a circuit quadrilateral. And in the situation of circuit quadrilateral, what happens is that what? Opposite angle of the circuit quadrilateral is what? 180 degrees. So I can say that the angle 103 here is opposite to this angle which I have here. So in that case, I can say that this angle plus this angle is 180 degrees. If I'm going by that theorem, then there's another theorem which I can use in case I don't want to say that what opposite angle of a circuit quadrilateral. So we can see this is a situation of circuit quadrilateral that is extended, that is, it has an exterior angle. So if the exterior angle exists like this, so there is another theorem which shows us that what exterior angle of circuit quadrilateral is equal to the opposite interior angle. And to obtain our opposite interior angle, the first thing one has to do is to know what is the angle beside such an exterior angle. So we can see that the angle which we have beside that exterior angle is 103 degrees. So which means any angle facing, and that is any angle which is directly opposite to this angle 103 degrees will be equal to the exterior angle. And which of the angle we have on the board here is opposite to this angle 103? We can see it is this way. So automatically, without wasting our time, without engaging in any form of workings at all, you can simply say that this exterior angle is what? Equal to what? This interior opposite angle. It's an interior angle which is opposite to this exterior angle. In that wise, we can say that this place is what? We can say this place is as well 77 degrees, but the naming to this one is not given. Let me check it for my question. So nothing is there. Now, okay, let me call it any name. I can call it any name. So let me name this place. That place is now going to be named QMS. So in this wise, I can say QMS is equal to what? 103 degrees. So this place is 103 degrees. That place is 103 degrees. Now, what actually are we asked to find? We are asked to find PQO. So that is PQO. What we are interested in is this angle. Now, what do we need to get in this angle? So what we can do is we can treat what we have here, this entire small shape inside here. Let us treat it. And remember, we said this thing looks like a circuit quadrilateral. One of the jobs of circuit quadrilateral is to enable us to know. Now, this is not 103. I meant to write 77 degrees, not 103. So because the value here will be equal to the exterior opposite angle, it is 77 degrees rather than 103 that I initially put there. Now, what we actually want to do here is we can see that circuit quadrilateral properties, that the theorem of circuit quadrilateral has done all its best. Now, what we now have is we keep thinking, what else can we do in order to achieve the result which we have to find? Now, one of the things we can do now is circuit geometric properties, circuit geometric theory. Okay, we'll still have some work here. So one other thing we can do is, since where we are going, what we want to get is this. So what we can do is, I think we know this angle, we know this angle, and if it is possible with the little information we have, I can get the angle here. Once I can get the angle here, then it's very easy for me to get it. So I can just treat this one as a quadrilateral, and summation of all angle in the quadrilateral gives the value of what? 360 degrees. So with that, I just add everything and subtract from 360 in order to get it. So the next thing I want to do is, how can I get this? So remember the type of shape given to us here. Talks about the relationship between angle at the center as well as angle at the circumference. We have a particular diagram that uses this place as the center. Let's just focus on that one. So when we consider the lower diagram, that is this, and this, that situation uses this place as center, while it recognizes this place as what? As its own circumference. So that is the area where we want to focus on. So in that case, we say that this angle at the center is twice the angle at the circumference. So we can say angle at the center here is O, or what we can name QOS, So that shows that QOS here is 2 times whatever angle we have at what? At the circumference. At the circumference. So I can say that. So in this case, it shows that my QOS is equal to 154 degree. So this place is 154 degree. So I haven't gotten this now. We've exhausted all that circle theorem properties. That is, circle theorem properties can be done. To getting this thing, all we have to do is this. We can say the addition of everything in this quadrilateral here. You can see this quadrilateral we have within here is not exactly quadrilateral, it's an ordinary quadrilateral. So we can say the addition of everything here is equal to 360 degrees. So in that case, we can say Q, and Q here, what we can call OQ, PQO. Let's state it the way it is given in the question. We can say that PQO plus any other angle which we have here, 103 degree plus 68 degree plus 154 degree is equal to 360 degree. That's the sum of angles in what? In the quadrilateral. So in that case, we can say that PQO is plus. So that may be for me to add everything I have here. I have 103 plus 68 plus 154. So that gives what? 325 degree is equal to 360 degree. I hope it is clear this way. So to get PQO now, we collect the right side by saying that PQO is equal to 360 degree minus 325 degree. And that gives the value of 35 degree. So it shows the requirement of this question. That is, the PQO which we have to find here has the value of 35 degree.